And welcome back. Now today I want to talk to you about a means of communicating via email, because as part of my Home Alone project, which is what this little module here, well, series of modules, these are all Wemos D1s in fact, and they're part of my Home Alone project. Now that's all fine and dandy, but one of the things I did need to do was send an email. Now I have my own domain, so therefore I also have email that comes along with it, and I can make up to 50 email addresses for that domain. That's great, and it's very, very easy to do. But I'm thinking, maybe not everybody has their own domain. In fact, I know for sure that most people don't. So I thought, what's the most common mail provider in the world? Pretty much, I'd say probably, I'm guessing here, but I'd say Gmail. Okay, so I thought, right, what I'm going to do then is send my mail via Gmail just to prove it can be done. So that's what this video is about. And we're not using this here, this makeup here, which is, as I said, a series of little D1 Mini modules. So you've got here a sort of a triple base plate. We've got an SD card reader. There's the actual Wemos D1 in there, ESP8266. That's a power shield. That's a development shield. I've just got a single LED on there at the moment. And here's my little TFT, which you saw in the previous video when I showed you all this. That's the one on screen now. So if you want to know a little bit more about this, have a look at that video. Oh, now as you can see, I've touched something that I shouldn't have touched. In fact, I touched the analog pin over here. So this thinks now I'm doing something. So we'll just leave that quietly beeping to itself to one side. It will stop in a minute. While we talk about Gmail. Now I was going to show initially on this device here, this is in fact an ESP32 ESP32 W room. You can just about say it on there. Nobody quite knows what W room stands for. Wireless room, nobody knows, frankly. All right, maybe Espressif will tell us one day. Anyway, this ESP32 is connected to this SSD1306 TFT display here, and that'll be a subject of a separate video. Very nice it is for well, both development and production, actually, I've got to say. And my goodness, is that chip fast? I mean, I've been working for hours and hours, dozens of hours on this project, and it's okay for speed, but this ESP32 just runs rings around it. It really does. And for displaying on a TFT, of course, that is always very useful. However, we're not going to be using this, so let's quietly put that away. That might be the next video. So the development board that I'd normally use is this one here. Let's just move this one out of the way without setting it off again. So I'm just going to use a Wemos D1 here. So this is the standard ESP8266. I think this is a 12E, might be a 12F chip, don't know, it doesn't matter. But it's on this Arduino size board, standard USB interface. That's what I like, the micro USB, plus you can power it up, and you've got a single reset pin. So this is version 2 of this board, or release 2, R2, because the previous one had 2 reset pins, or 2 pins here. One was a reset and one's to boot, and you have to fiddle about with them in sequence to get the thing to load up. All that's gone there. You don't have to do anything to load something up to here. Right, so let's talk about Gmail. And obviously this is going to be a code-based video because, well, that's how you send mail, isn't it? But that's what we're sending it on. If you haven't got one of these, I'd highly recommend it. They're very useful and easy to use, these particular boards, Wemos D1s. In fact, they're not made by Wemos anymore. They're now Lolin, I believe. Whether they've been taken over, bought out, I don't know. But anyway, they're good, and they're pretty cheap, I've got to admit, from the Far East. I'll just see if I can put a link in the video underneath, all right, so you can have a look there. Right, just before we look at the code, let's have a message from our sponsor for this video. Just wanted to let you know that LCSC Electronics, China's leading electronics components distributor, are sponsoring this video. In the heart of Shenzhen, China, they have a 10,000 square metre warehouse with a much larger one under construction, an investment of some 500 million renminbi. With their semi-automatic machinery, they can pick our orders to have it ready in 4 hours and sent via a variety of global shipping options. As an example, for orders to the USA, Europe and Australia, we can get them in just 3 days. Try them now. Right, okay, let's talk about the code for this. And remember, if you're going to use Gmail to send mail, you can do it, but there's a bit of a sting in the tail, so keep watching. So this is the code. I'm not going to go through every single line on this because A, you can download the sketch yourself and look at it. And it will be, if it's not already well commented, it will be by the time it hits my GitHub. So you can have a look at that. So we'll just go through the sort of basics. Also, the awkward thing is now, of course, I've had to hide some of my details on here, you know, my email address and password and stuff like that. God forbid that should ever get out in the wild. So I'm obviously having to sort of do a bit of smoke and mirrors, really. But what you can be assured of, that the code running on here is in fact the code that's up here, but just with a couple of things blanked out on here, so I'm not exposed to the wide world for malicious email. Right, okay, so let's start off at the top, and we say, you can read the comments in your leisure. We do need a base 64 header, because when you send your user ID and password to Gmail, you need to encode it into base 64, which is common to most SMTP servers. Okay, that's SMTP being your Simple Mail Transport Protocol server. It's been around for donkey's years, hasn't changed that much. But there is a little confusion going on, which we'll talk about as we get to it in the code. Right, we also need the ESP8266 Wi-Fi code. You can download that by selecting it in your boards for ESP8266. If you haven't done that already, I'll go through that now. So go to your Arduino IDE, load up the sketch that, hopefully my one that you've downloaded. Now, you've got to go first of all to File. If you haven't ever added ESP8266 boards before, go to Preferences, and then go down to this bit here where it says Additional Boards Manager URLs. Click this little thing on the right, and you'll see that there's this list of boards, and the one we're interested in are the 3866 ones, which is right at the top of the list. So add that in, which I'll put in the video description at the bottom, so you just copy and paste that in to that list. You might not have anything in here. If all you've ever used is an Arduino, then this could well be blank. So just copy in that top line, which says, I want to use ESP8266 based boards, please, and hit OK, and then OK again to close it down. So at that point, you're saying that's the source where you can go and find out about all this stuff. Now we need to go to Tools, select the board, but of course you won't have selected this yet because your system won't know about it. Go to Boards Manager. Now you have to wait. Look at this bit down the bottom here and wait until it's done its business. So we'll come back in a minute or so. Right, so it's done it now, right? The message down the bottom has disappeared. So now what you want to type in at the top here is ESP8266 to filter it just to those libraries. Now, as you can see here, mine says 242 and I've installed it. Well, it would be installed, wouldn't it? Because I'm using it, but if you haven't installed it yet, or if yours says 2.5.0, then you need to change that, because otherwise this ain't going to work. Now, as we can see here, there are a few options. 242, the one installed, is the one you want. The reason it's not in this list is because I've already installed it. We don't want any of these betas, and you certainly do not want 2.5.0 because it won't work, not with Gmail. So select out of this list 242 and then select Update, and after about, I don't know, another minute, it will look like this, and it will say, yes, that's it, it's done. Then you hit Close. And patience is a virtue here, because then you've got to wait now again while it sorts itself out. And until these buttons at the top here become responsive, nothing's going to happen. Okay, so as you can see, look, I'm mousing over them, but they don't do anything yet. This is I'm busy in the background, so just sit down, have a cup of tea, and we'll come back in another minute. Right, there we are. Now it's responsive again. All these little icons light up, so you know it's working. Now you can go to Tools. Go to the board, whatever you may or may not have selected, it might be blank here, and scroll down this list, because eventually you'll come to your ESP8266 boards. Now, I've got a huge long list here because I'm running with lots of different boards, but you might have quite a short list, just the Arduinos and then ESP8266 modules. Now, find your one. If you can't find the exact one, the one I'm using is the Wemos D1 R2. As you can see, it's actually made by Lolin now. I also got an R1 version, which is that one there. If you can't find your particular version of ESP8266 board, just choose a generic one here. Chances are it will work just fine. Now the other bits you need to sort out are all these variables here. These will be pre-filled according to which board you select out of the ESP8266 modules. But I would say upload speed of 92.1600 is good. That works for me. I would say 49 times out of 50. Occasionally you get a failure because it is quite fast. CPU frequency is 80 megahertz. You can double it to 160. I've not tried that recently. I did it months and if not a year ago. Spiffs we don't need to worry about. Just choose the one with the smallest spiffs because we're not actually using spiffs. Some boards allow you to select 0 megabyte spiffs, but just select the smallest one, which will give you the biggest memory for actual programs. Debugging port is disabled. Debug level is none. I have all that big long list. This is important. This LWIP variant, if you don't select V2 lower memory, you'll get problems eventually. Yesterday, for example, I had this set to higher bandwidth and wondered why my program kept crashing. So select lower memory. VTables go to flash. Erase flash. What that means is when you upload a sketch, what do you want it to do? Just upload the sketch, all the Wi-Fi settings as well, or everything on there? Well, I've got mine to sketch only because one, I don't want my Wi-Fi settings removed every time, and I'm not using flash anyway. The port is the one you've got your board plugged into. If your board isn't plugged in, now's the time to do it because you won't see it. And that's it. Make sur your program is still set to AVR or SP Mark 2. That's the standard one. And that's it. Once you've selected your particular board, once again, have a little bit of patience for it all to spring into life here. And that's good. Then it will start knowing about ESP8266 Wi-Fi and things like that. Great. Right, that's the confusion about the libraries then. Have to be very careful with those. So in my header file, this config header here, that actually contains all this stuff underneath, except of course I'm not exposing my details here to the whole wide world, but that's basically what it contains. All right, and it's just an easy way of keeping your details to a readable file that you can edit as you go along without having to muck about with your actual code. Obviously you still need to compile the code. If you want this sort of data to be editable on the fly, then you need to include it as something like an SD card or well, that's about it really, SD card. Even if you read it off EEPROM on the chip, you've got to get it onto the chip, and that means a new sketch uploaded, and it's all a bit messy. So for the time being, I'm keeping it in a config file. For my Home Alone project, I do actually, as you saw there, perhaps briefly, let's get the blue tack out of the way. You did see an SD card there, and that SD card contains many things, not just the Wi-Fi details, but parameters for the actual program, things that you might want to tweak as you're going along. So you got things like, yes, your Wi-Fi name, your Wi-Fi password, your mail login user and password, and then possibly things like timeout values or error message email addresses where you want things to be sent, all things like that that you don't really want to recompile the code for, and that you can read in off an SD card. Moving on. Right, so what this is reading in here is my SSD. Fingerprint we can forget. We're not using that with this particular library because it's not supported. Okay, so we just have to hope the best we can get to the right server, no man-in-the-middle attacks. Right, so we set up our client from the Wi-Fi secure. Now this is important that it is secure because it means that you initially set up a secure connection to the server that you're talking to, and you'll do that as you'll see in a minute. I'm not going to talk about all this code here because that was, I've gone through that many times in the past, and it was in the last video, and it's out there like this pretty much in every single internet example you can find. All right, so it's a standard way of doing it. Right, sending the email then. So, in fact, we can read that comment. So what we do here, we can say, well, right, we're attempting connection to the Gmail server on port 465. What's port 465, Al? Right, glad you asked about that. Port 465 is the secure connection for SMTP. All right. Now you might say, oh, what's the other port then? What's 587? Glad you asked that as well. And what about 25? Yeah, okay. There's 25 as well, but you never want to connect to that because it's plain text. Okay. So what we do, we connect to the server using port 465, and the library behind the scenes is already negotiating a secure connection for you immediately as soon as you make that connection. Now, port 587 starts in plain text, and then you have to issue a command, start TLS, which basically flips it to the same sort of encryption protocol as what this uses straight away. It goes, let's communicate. Let's think how best we can explain this. Let's imagine I'm James Bond. Yeah, imagine, all right? Now, I've got a phone or a walkie-talkie. Let me go back to my main. Right, so I've got this walkie-talkie, right? And I want to talk to headquarters. But this is an open phone or walkie-talkie, and it's not secure. So I dial up headquarters, dick, and I say, Bond, go to secure channel 42. So at the other end, they do their business and go to 42. I press 42 on here, click, secured. Now we can talk because we're now encrypted together, okay? Before that, anything said before that could have been eavesdropped upon by somebody else. Now, even if somebody had been listening at that time, we're talking about email servers now, and they go, oh, somebody's made a connection to a server here on port 567, which means it's not encrypted initially. Sorry, 587, it's not encrypted initially. Let's listen. Well, the only thing they're going to hear is, go to channel 42. Click, that's the end of it. And of course, the eavesdropper cannot get onto channel 42 and intercept whatever's going on because they have no idea what channel 42 is, apart from the meaning of life, universe, and everything. So that's how port 587 works, except that it's all a bit messy. They invented 587, that is TLS, because they thought, why are we going to port 465 always encrypting if we don't need to? All right, we've got 25, which is totally unencrypted. We've got port 465, which is totally encrypted. And then we've got this 587 now for TLS. So why don't we just start on 587 and encrypt if we need to? Well, as you can imagine, the world moved on before these standards were introduced. And suddenly they had millions and millions of PCs all talking on either 25, not so much these days, I wouldn't have thought, but certainly port 465, and they weren't going to move them over to 587. So although they've kept it going, I don't think there's a chance of a snowball in hell of actually ever getting rid of that. So we're going to start with 465 and just encrypt from start to finish. Why not? Why do anything different? Okay. Now, at this point, we're waiting for Gmail to respond, okay, at which point it should do, and it goes, okay, I'm here, and you send this extended hello. So you say extended, that's what the E stands for, hello Gmail, and it comes back and goes, hi, who are you? All right, and you go, okay, well, I'll send you my login details. So you say, I'm going to send you that, and it goes, okay. So you send in your base64 encoded user. That's why we need to use base64 include library right at the top. Don't ask me why. It's one of those things buried in the mists of time, but you do need to do it that way so it can basically support all the different character sets. But anyway, so you go, this is me, all right? So this is Ralph at Gmail. And he goes, yeah, give me a password. So you go, okay, here's my password, also encoded in base64. And it goes, that's fine. I know who you are. That's great. Get on with it. And then you say, right, I'm sending mail from this user. And as you can see on here, it's a totally made up name, but if I did have one called Arduino Power, that's how you do it. Now, bear in mind, Gmail is very picky. You must include these angle brackets here and here around the name, or it will just fail. It will go invalid username. Don't ask me how I found this out, but it took me a little while. Ditto, when you send the email address, so sending to, receipt to in this way, so ralph@gmail.com, that's not my real address, don't bother sending email there, just in case there is somebody called ralph@gmail.com, you won't appreciate it. You have to put the chevrons, angle brackets, round that name as well. Yeah, and you repeat that line for each person you want to send email to. Simple as that. Eventually you say, right, I've done with all this sending from and to lark. I now just want to send the actual email. So you say, I'm sending the data. And Gmail says, okay, get on with it.
So now you say, right, I want the mail to go to this totally made up name. Okay, so you can put in there some kind of what could you put in there? Well, a group name, as I've got in there. I've got a Home Alone group, for example, right? And you put Bugs Bunny. You can do anything you like there, just to differentiate that particular mail from, you know, your personal email. Not that your personal email is going to be hidden; it won't be. Anybody can look at the headers and find out where this email has come from. But the email that is displayed on screen in a client like Outlook or Gmail will be that one there. And you say it's from this person. And that also can be totally made up. All right, that's what it looks like in the Gmail client. And then you just print in the subject and then the lines of the body. Fine. And you keep doing that until you get bored with sending the body. And then, now this is important, right? You must send a dot on a line all by itself. Now, what does that mean? Well, as it says here, client print line dot, this F, by the way, in front, means that all these strings are stored in program memory, not in runtime memory. Just saves a bit of space. Probably not required, actually, for the ESP8266, but if you're doing this in Arduino, you definitely are a bit short of RAM, so yes, use that. Now, what it means is, if this is going to be on a line by itself, the previous line must also end with a print line, not just a print. Right, so if that was a print, you go, okay, you've given me a bit of a line, where's the rest of it? And it's the line bit at the end of this print line that terminates it. So if you don't have this line on the previous one to this one, it won't accept this dot as a dot on a line by itself. You might have to rewind that bit of the video to make it clear, but basically this has got to be on a line by itself, print line, and therefore the previous line must be as well. Okay, simple as that. It will then say, okay, yeah, that's fine. I've understood you've finished your email now. And it will go, I'm now finishing the email up. And you go, yeah, quit, I've done. And it goes, fine, you're finished. You're out of here. And it sort of basically kills your session, sort of, or throws you out. And then you must do a client.stop. Otherwise, you're going to build up the memory in your program and never actually release that memory and not terminate that connection cleanly. And that's about it, really. This response code at the bottom, once again, this, incidentally, is out there on the internet. I think everybody uses it one way or another. It just checks the response for each one of these things that you're sending to Gmail or whatever mail provider you're using. We check the response to make sure that it was okay. The response was 1. Okay, and that's it. That's how it works. Now, you want to see this in action? I'm afraid there's a bit of a disappointment. I can't actually send this, but what I can send is the one I uploaded to the Wemos D1 earlier, because obviously this contains some rubbish emails and Gmail won't accept that. So let's load up the debug window, i.e. the serial monitor window, and see what that says. Looking good, looking good. So if we scroll back to the top of this, I'll tell you what, let's just do it again, shall we? Let's clear this. Bink. And I'm going to press reset on this one here. I'm going to press reset here, and we'll watch it all spring into action. Well, we hope it's going to spring into action. Let's have a look. There we go. Rebooted, connected. Oh, look at all that. Just as I said it was going to happen. And now we're disconnected. Let's just whiz through this very, very quickly. So we're connecting to Wi-Fi here. We're attempting to connect to the Gmail server using port 465. The response coming back is, I'm connected. You say hello, or extended hello in this case, and it goes smtp@gmail.com at your service. And you go, and it goes, these are all the things I can do. Look, I can allow you to send the mail up to that size. I can have 8-bit MIME. You can authorize, you can log in, you can have plain text, you can do all these sorts of things which we're not really interested in. Enhanced status codes, blah, 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 blah. And then eventually we say, look, I'm sending you my authorized login name. And it goes, okay. And it comes back and goes, what's your username then? So you send that. And then it goes, what's your password? So you send that. And it goes, accepted. That's the magic line to say, yes, everything. You are now logged in to the Gmail server. Great. And then you say, well, I'm sending it from that totally made up name. I'm sending it to, well, a real recipient. Otherwise, of course, it's never going to get there. Now I'm sending the body of the mail the way I want it to appear in somebody's inbox.
and send, and eventually you send quit, at which point it says, I'm closing connection. This is Gmail telling you now, I'm closing the connection. So you say, fine, I'm disconnected, I'm shutting down my client. And that's it. It stops there. I can't scroll any further. That's the end of it. All pretty simple stuff, isn't it? In one way and another, it just seems to work. But remember, in order to do this, one, you've got to have the correct version of that library, 4.22. Don't go any higher than that because it just will not work. What version did I just say there? The library version has got to be 2.42. Don't go up to 2.5. It won't work. Don't know why yet. I'm hoping it'll be fixed soon. And yes, there is a sting in the tail. Look at this output here that I'm about to put on screen on top here. I'll talk you through it. Right, so this is a snapshot of something I took earlier and caused me no end of trouble. Right, so to avoid you having that sort of trouble with Gmail, and it's only Gmail that has this problem. As we can see here, if I just whiz through, this is my ESP8266 booting up, connecting to my Wi-Fi, all hunky-dory, talking to the server, saying hello, it's saying, yeah, I'm here, these are all the things I can do, sending your authorized Gmail login, great, and it goes, send me my user, what's my password, and it goes, no, I don't think so, I can't accept that, no, can't do it, no, 53. Error 53. Go to the internet, you'll find approximately 8,000,496 trillion results, all with that. And it's basically Gmail being awkward, or Google. Well, okay, it's not quite as simple as that. What Google is saying is, look guys, we all know that email is a constant source of spam and problems for us and people attaching things, which our servers will hopefully prevent a lot of that. But we can't then allow every Tom, Dick and Harry to send email via our servers in the way that I've just shown you how to do. Yes, you've got to have an authorized Gmail account, but I mean, how difficult is it going to be to set one of those up, right? And you can send out spam before Gmail eventually kick you off, but by then the damage is done. So what Google is saying is, we're not going to let you send email via these third parties, basically your Arduino or ESP8266 or what have you, because it's not secure. So tough luck, you're going to get response 53. Okay, bye. How do we get around that? Well, there is a way, but this is the sting in the tail. You have to go to your Google account and bring up this page. Right, this page here, it's on your Google account. It's under security, less secure apps. Some apps, blindly by, you can read that as well as I can, but basically we're telling Google, no, I will allow less secure apps, i.e. apps not written by Google, like Gmail or whatever, access to my account. I've switched it on. Okay, this button here would normally be slid to the left and grayed out. I'm not going to do it now because it takes forever and I get a dozen emails from Google saying, are you sure? So you have to allow other parties access to your email account, and Google will make you believe that the universe will implode if you allow this. These are the sort of emails you get from Google if you switch this on as I have here. So this one says, someone's just tried to use a blah, 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 blah. Yeah, he goes, are you sure this is, absolutely not. Surely you don't want to do this. Well, you have to go to the link they give you and say, yes, it was me who did that actually. Yes, I know I'm being foolish, but I'm going to do it anyway. Okay. What else do they send you? So they also send you an email that looks like this. Excuse the scribbles on it. Obviously, I don't want to expose my proper email address. So they send you this. And where it says check activity and that blue button down the bottom, that's what you need to click sometimes and say, yes, it was me that did this. I know what I'm doing. And it goes, all right then. The world will end in 5 minutes and the universe will implode, but that's okay then. Google do not want you to do this, with good reason. We can understand why they're doing it. But if you want to send emails using, well, an Arduino or Raspberry Pi, ESP8266, all those things, you're going to have to downgrade the security level on your Google account to allow less secure apps. I don't know what they mean really by less secure. It's less secure in the sense that Google didn't write them.
but you know, there we are. So that's what you get, and well, that's the price you pay. Do you really want your Google account to allow other apps to access it? I personally don't. So I'm going to probably switch this off in a second. As soon as I finish this video, I'll be switching this back off, because I don't need to send email via Gmail. I can send it via my own ISP's domain. Well, I've bought a domain specifically for me. Few of you may know what that is, because you've sent me emails and I replied to you from that account. So, and I can make up 50 emails, so I can use one specifically, if you like, for my Home Alone project. Great. But for those of you who don't have it, Gmail is the only option. This is what you're going to have to do. It's a price you pay. And if you do get hacked by some evil person out there, I don't know how easy it would be to hack the account, but if you did, I don't think Google's going to have much sympathy, to be quite honest, because they said, we told you so. We said the universe will implode, now it has. So just be cautious when you do this, and perhaps do a bit of internet research about how open this makes your account. It doesn't make it open to the world, but it does make it less secure. Right. One final thing then. We said at the beginning, do not use library 2.5.0. You must stick to 2.4.2, because if you don't, this is the message you get. You say, right, you've logged into your Wi-Fi at home. That's fine. And I'm now attempting to contact Google, Gmail, and it goes, no. That's it. No explanation, no error code, just no. Yeah, I know. That's the trouble when you start taking on different versions of the libraries that haven't been fully tested with all particular brands. Yeah, so if you do get this, you'll have to downgrade to 2.4.2 again. Just saying, all right? Because it's very frustrating to write a bit of code and wonder why you're getting a stupid error like this, okay? Or indeed that other error 53. And when you do, by the way, when you do click this little button on here, to say, yes, I'm happy for less secure apps, it doesn't take effect instantly. It can be sometimes a few minutes before it let you send email via your Arduino or ESP8266 or whatever. Okay, right, I think we're probably done with that. That's how you send secure email with Gmail, but there is that sting in the tail that your entire Google account is now allowing access to other apps that you perhaps might not want them to. Okay, and in the future we'll be talking about more about this project here, my Home Alone project, which is working rather nicely at the moment, sending me emails actually, but not via Gmail. Okay, right, any comments, queries or anything else, put them underneath the video. I'll read all your comments and probably reply to just about every one of them. And what else can you do? Well, you can subscribe to this channel if you like. That'll be absolutely super. Come along with my Arduino journey. And thanks for watching. See you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.